Welcome back, Pre-Calc. I hope you are well. Our objective today is going to be to graph ellipses by hand. I've got the checklist on the screen. You know what to do from here. Okay, will you please pause the screen and copy what I have? Let's go ahead and pause. Okay, hopefully you paused. We are back. So a hyperbola is the last kind of conic section that we have, and it is a set of all points. You're going to notice it's similar to how an ellipse is defined. It's a set of all points in a plane such that the difference of the distances to the two fixed points is a constant. So instead of the sum, like an ellipse, it's going to be the difference between the two. Okay, so you're going to see a lot of familiar vocab here. So your foci are those two fixed points. So I kind of got them in purple here. Your vertices are the endpoints of, instead of having like a major and a minor axis, we call them the transverse axis and the conjugate axis, okay? So the transverse axis is the axis where you open up on. So like this has a horizontal transverse axis, right? Because you're opening horizontally. You can also open vertically, right? And you've got your co-vertices, so those are the endpoints of the conjugate axis, similar, kind of analogous to your minor axis of ellipses, and then of course your center, okay? So let me show you kind of a couple more general hyperbola. So one unique thing about hyperbolas that none of the other conic sections have is that they have these asymptotes, right? And like these slant asymptotes. So the way we find those asymptotes is, what I like to do is I like to plot both my vertices, these red dots here, as well as my co-vertices, in this case these purple dots. And I make a rectangle there, and then if you connect kind of the diagonals of those on the rectangle, that's what's going to create your asymptotes for you, okay? So you're going to need your asymptotes and then your vertices to see where sort of the path that these hyperbolas open up, okay? Now, your new Pythagorean relation, please write this, is actually c squared equals a squared plus b squared, okay? So a little bit different than what we saw with ellipses, okay? And how do we know whether it opens horizontally or vertically is actually which variable comes first, okay? So not which one has the larger denominator anymore. It's if x's come first, then it's going to open horizontally like you're seeing here. Let me show you. If y's come first, it's going to open vertically like you see on this slide. Why do you think that is? Well, here we're subtracting, right? It was a set of all points whose difference is a constant. So when we're subtracting, order matters, right? So if we go y minus x, the y terms minus the x terms, it's going to look like what you see here, opening vertically. X terms minus your y terms is going to open horizontally. Okay. All right. So let's also label. Can you put please A, B, and C in your notes? And let's do some vocab here. Okay. So A is the distance from your center to your vertices. You go ahead and write that. So again, make sure you write that. A is the distance from the center to vertex. You can see that on the graph here. B is going to be your distance from, hopefully you can see it there as well, center to co-vertex. And then C is still going to be your distance from center to what? Can you tell there? Focus, yeah. Okay. So for example, like the length of your axis here is going to be 2a, right? And then 2b, because you've gone, up b units as well as down b units, so you'll have a length of 2b. And again, I just want to show you this screen one more time if you wanted to pause and write this down. So your formula looks really similar. Notice HK is still your center, right? It's just that if your y's come first, if you do y minus x, then you're going to be opening vertically. Okay, I'm going to force a pause on your screen. Would you go ahead and copy the equation as well as the 5 words I have there on the left, and then we'll do this together. Okay, we are back. So first thing I want to ask you is the direction. In other words, is this hyperbola going to open horizontally or vertically? So this is going to be horizontal. And the reason here is because x's come first, okay? So it's different from the ellipse where you see, okay, which one has a larger denominator? That's not the case. Remember, we're subtracting, so order matters. X's come first, so we will be opening horizontally. All right, now the center, we're going to grab it the same way we have been. So remember, inside parentheses is opposite. Go x comma y. So we've got -2 comma 5. So I'm going to go ahead and plot that. Now to get our vertices and our co-vertices, we need to figure out our A and our B. So again, A comes first in this case. Again, it's not necessarily which one's larger. So A is going to be the square root of 9. So A is 3, and B is going to be the square root of 16, which is 4. Okay, and while we're at it, let's go ahead and find C, which your Pythagorean relation is C squared equals A squared plus B squared in this case. So you can see that it's going to be a 3, 4, 5. All right, so let's go ahead and plot some of these here. So let's start with our vertices. I said it's going to be opening horizontally, so I'm going to move from my center 3 to the left and the right because A is 3, okay? So let me grab my pen here and see if this works. Okay. So I'm going to go 1, 2, 3, and then to the left 3. So basically I'm adding and subtracting 3 to my x-coordinate from the center, okay? So if I take the x-coordinate and add 3, I would be at 1, hold the y-coordinate. And if I take my x-coordinate from the center and subtract 3, I'd be at -5, again, hold the y-coordinate. Let's do the same thing with the co-vertices. So now I'm going to use my b value. And my b value is 4, so I'm going to go up 4 from the green dot. So 1, 2, 3, 4. There we go. And down 4. 1, 2, 3, 4. Right about there. Okay, so we're going to come back if we want to do this more kind of algebraically. Take your center and add and subtract 4 to the y value here. Okay, so keep your x. Adding 4 would give me 9. Again, keep your x, subtracting 4 from the y value would give me 1 there. Okay, our foci, we're going to add and subtract 5 from the center to the x, because if this was a horizontal, we decided a horizontal opening here. So if I add and subtract 5 to the x-coordinate of the center, so adding 5, that's going to give me 3, hold the y, and subtracting 5 here is going to give me -7. Okay, so now let's go ahead and plot this. See the 4 dots made with the vertices and co-vertices. I'm going to do my best here. Maybe should have used my iPad for this. My tablet here is a little bit difficult. So I'm going to do my best to make kind of a rectangle there. And what I'm going to do is again, kind of draw through the diagonals of this rectangle. So let me do that. All right, so I have connected the corners, basically. Now come back to your vertex. And we're going to sketch our hyperbola, and it is going to, very much regretting not using my iPad here. So there it is, cleaned up a bit. So here's our vertices here, right? And then you're just going to follow those asymptotes out, both on the left and the right. All right, I'm going to force a pause on your screen. Go ahead and copy the equation as well as the 5 words on the left. All right, so you probably guessed we need to do what here? We need to complete the square. So let's go ahead and collect our x terms. Leave a little bit of space. Collect your y terms. Notice we have no other y's here. And then we'll move our constants over, right? Okay, so now we need to decide what do we need to add to complete the square for the x's, but before we complete the square, we have to factor out that 4, correct? And the y's, since I just have the y squared, I'm good there, so I'm not going to need to complete the square. I'm not going to need to add anything for the y's. All right, but for the x's, what do you want to add? Yeah, half of 2 is 1. 1 squared is 1. So I'm going to add 1 here. Be really careful though, because it's inside parentheses. It's being multiplied by that 4. So I technically did not add 1 to the left. I technically added 4. So be sure you add that to the right as well. Okay, let's do a little bit of algebra here. So we've got 4 times the quantity x plus 1 squared, right? Minus 3y squared. Then on the right-hand side, I have negative 16 plus 4, so I'm getting negative 14. I'm sorry, negative 12 there. Good deal. We like those. So I'm almost there. Remember, I want 1 on this side, so I need to divide everything by negative 12, right? So if I divide the right side by negative 12, of course I get 1. Here I need to divide the whole side, so both terms. So I want you to pay attention here, because if I divide negative 3 by negative 12, it actually becomes my positive, right? So I'm actually going to put the y squared first, and 3 over 12 reduces to 1 over 4. Okay, now coming back to my x terms, if I divide this by negative 12, 4 over negative 12 reduces to negative 1 over 3, right? And I still have that x plus 1 squared in the numerator. Okay, so I kind of did 2 steps there at once. I just realized, oh, if I'm dividing by a negative, my signs are going to flip, so actually my y's are going to come first, because subtraction order matters, right? Okay, awesome. So what direction would you say this opens, vertically or horizontally? This is going to open vertically, because the y's come first, correct? So let's grab the center. Make sure you go x then y, and inside's opposite, so negative 1, comma, 0, right? So I plot that there. All right, my vertices. Well, let's, again, always list your A, B, and C before you go vertices, co-vertices, and foci. So A, remember, it's the first one, but this is a squared. So A is actually square root of 4, so A is 2. B is going to be just the square root of 3, so that's irrational. And then remember, C squared is A squared plus B squared. So 4 plus 3, right? So C is actually going to be square root of 7, okay? So if I want to find the vertices, we're opening vertically in this case. So you want to take your A value and add and subtract it to your X or your Y? Your y from your center, okay? So I'm going to go hold the negative 1. If I add and subtract, let's see, 2, if I add, I get positive 2, right? And if I subtract, I get negative 2. So now for our co-vertices, we are going to add and subtract square root of 3 to the center, right? But for what coordinate, your x or your y? Now you're going to take your x, right, because it was opening vertically, so I already took care of my y's with my vertices. Now we're going to add and subtract 3 to the x coordinate. So what I'm going to do is I'm just going to write negative 1 plus or minus root 3, and then hold my y coordinate. Okay, and root 3 is between 1 and 2, right? So I'm going to kind of roughly plot those and plot my little box and kind of show you what the hyperbola looks like here. All right, so kind of that's roughly sort of what the parabola looks like there in the black. All the blue, the rectangle, and the asymptotes, those are guides, not part of the graph itself, but these 2 branches here, those are your hyperbola. And again, if I wanted to find the foci, I would add and subtract C to the center. Which coordinate of the center, though? The y in this case. Again, whatever variable came first here, okay? Again, order matters with subtraction. So it'd be 0 plus or minus root 7. I don't need that 0. Good deal. All right, I'm going to have you try example 3 on your own. So I'm going to force a pause on your screen. What I'd like for you to do first is just get it in standard form for me first, okay? So go ahead and complete the square. Make sure you get 1 on the right-hand side, and let's check from there, and then we'll go ahead and check the 5 things, the 5 aspects I'm asking for on the left as well. All right, this is what I got. So if this is not what you got, maybe pause your screen and see what you need to fix. One thing I do want to notice, or want you to notice, is that you do need to factor out this negative 1 here. So that is actually, even though you add a +1, you're technically adding a -1 because it's inside that set of parentheses, which is connected to a factor of -1 on the left. So that's why I have a -1 here as well. All right, so now what I'm going to do is force another pause on your screen, and you go ahead and fill out these last 5 aspects, and then let's check your answer. All right, so I've got answers on the screen. If this is not what you got, go ahead and pause and fix whatever you need to fix. All right, so for this last one, I would like for you to pause. You don't need to write any of this down, but go ahead and decide kind of mentally. There's going to be there's one circle, one parabola, one ellipse, and one hyperbola. Can you figure out which is which here without trying to get it into standard form? Okay, so this is what we call the general equation. Can you figure out which is which? Okay, so go ahead and pause and see which one's the circle, which one's the parabola, which one's the ellipse, and which one's the hyperbola. Okay, we are back. So, what do we think? A, did we get circle, parabola, ellipse, or hyperbola? So what I want you to actually look at is this can all be determined by just looking at your square terms, okay? So since you have just one square term here, only the x's is squared, this is going to be a parabola, okay? Now, what I want you to look at next is which one, B, C, or D, your coefficients for your x squared and your y squared terms are both the same. D, right? So what do you think that is? The circle, the ellipse, or the hyperbola? That's going to be your circle. It's the same all the way around, okay? Now, B and C are left. Do you think that B is the ellipse or the hyperbola? This is going to be the hyperbola because your terms are being squared, right? And then C, this leaves us with the ellipse. So your square terms are being added, but your coefficients are different. Okay, you all, that is what I have for today. Go ahead and write a summarizing sentence, and I will see you all in class.